welcome to our channel, guys. So this is the continuation of elements and atoms. So the first group will be group 1. So we mark the groups right in the Roman Latin numbers. Second one will be 2, 3, third one. Then we have 4, 5, 6, 7 and 8. So the 8th group we also call it as 0 group, right? So what about the rows? For the rows we say periods. So this is the first period, the second one will be the next period. So now you need to understand that the electrons in group 1 will always be 1 electron. The outermost shell electron will be 1 for all the elements in the first group. Outermost shell, there is another name called as valency shell electrons. So for group 2 it always will be 2. 3 it always will be 3. Likewise, in the period if you see, the shells, the electron shells would be 1 in the first period. In the second there would be 2 shells. In the third there would be 3 shells. Hope you understood. Right? Now, a group will have similar properties. The chemical properties also will be similar. Right? Now we are going to consider the electron configuration. So, electron configuration gives an idea how the electrons are arranged in their orbits. For example, if I take carbon, the atomic number is 6. So, the number of protons in carbon would be 6. Atomic number is equal to the number of protons. So always an atom will be found as neutral. So it has 6 positive means 6 electrons, 6 negative. So that's why it can be neutral. So if we are drawing the electron configuration, I already discussed in the previous video that the first shell can hold up to 2, second shell can hold up to 8. So there is, if 2 is gone, in 6 we have 4 more. So we draw like this. We draw a nucleus and then it's surrounded in the first layer by 2 electrons. So I have drawn by 2 circles denoting the electrons. And the second layer there is 4 more. Right? Hope you understood. Now let's consider another example such as sodium, that is the symbol is Na. For sodium, atomic number is 11. So, first can hold up to 2, second can hold up to 8, and so there is 1 more. So we draw like this. The nucleus, and surrounding that the electrons, 2 in the first, 2, 4, 6, 8, and we have 1 more. Right? So now, if you see sodium, it has 3 layers, right? So that means it will be found in group in the period 3rd period. And it has 1 electron in the last valency shell. That means it's found in the first group. Electrons, the outermost shell electrons will be equal to its group. So it's found in group 1 and 3rd period. 3rd period. Group 1, 3rd period. So it's very simple. We'll consider some other examples. Right? Now we are going to consider oxygen. Atomic number is equal to 8. That means 8 protons. Atomic number is equal to the number of protons, so it should be 8 protons. So if the protons and neutrons should be equal, because the atom is said to be neutral, so it has 8 electrons. So first shell it can hold up to 2, and the second the rest 6 will go. So we can draw it like this. Oxygen, and we have in the first orbit 2 electrons, and in the second orbit there is 6, so it will be 2, 4 and 6. So drawing these electron configurations, it would be very simple, and you just need to have some practice them while following the video. You can do some practice, right? So we can talk about in the period, if you see the group 8 or the 0 group, we say 8th group or the 0 group, right? It's very stable, because stability is high, because the electrons would be always packed to the maximum number, right? So we'll take a member from group 8. The common examples of the group 8 would be neon, having an electron number 10. An atomic number 10. So it has 10 electrons, because atomic number is equal to the proton number. So that is equal to the electron number. So we can draw neon 2 and 8. So neon. If you see the second layer of this group, it is always filled to the maximum. So we call that as inert. They're very stable and they hold up to the maximum. So we call them inert. And inert gases, very stable. Right? Likewise, you can see for argon. Because so these electrons do not participate in forming bonds, because they are already very stable and they complete the orbits, right? So let's consider for argon also. Argon, it is 18. So the electron configuration will be 2, 8, that is 10, and the next orbit would be 8. So I am drawing very quickly. 2. So all these even for the other groups like sodium, potassium, then for the other elements, you need to do a practice. The more you practice, the more quickly you can draw these diagrams. The electron configuration is going to be very easy for you all. Hope you all understood this very well. Let's wind up this session.